Hello everyone, I welcome you all to my YouTube channel Science with Shekhar sir. So in class 9, we are going to discuss the new chapter today, that is force and laws of motion. As you can see on the screen, the bike is in motion. In the previous chapter we have studied about that when the body is said to be in motion, when the body is said to be at rest. So here in this chapter, we are going to study about the cause of this motion. In the previous chapter, we studied about the motion, acceleration, velocity, types of motion. But in this chapter, we are going to discuss about the cause of this motion. The cause of this motion is lying in the name of the chapter, that is force and laws of motion. So dear children, this chapter has been divided into two parts. One is force, another is laws of motion. In the one part, we will study about the force, types of force, units of force, and then there was a famous scientist, Newton, who studied the force and the motion and gave his laws that are known as Newton's laws of motion. So without wasting too much time, let's start the chapter force and laws of motion. So what is the meaning of laws? Laws means when something specific, we give a statement, right? Laws means, right? The meaning of law is means of motion. So rules. So meaning of laws is rules. That means the rules which has to be followed during the motion. Okay. A motion, we know very well that in the previous chapter we have already done. The body is said to be in motion if it changes its position with time. Right? Now the question is, what causes motion? As I told you, in this chapter we are going to study the cause of motion. Before going to the statement, let's consider a few examples. Now you can see on screen, here are few persons who are pulling a wagon, train, right? So what are they trying to do? They are trying to bring it in motion. Maybe it is at rest, right? So why they are pushing? Because we know that they are trying to give it motion. They are applying force. While pushing, they are applying force. Similarly, you can see on the screen now what happens here in this screen. We can say that the car is being pulled by the tow van. This is tow van and this is pulled by the car. Now here pull is also there, but pull is also a force. So what we conclude from here? The cause of motion is force. In both the cases, in one case it was push, in another case it was pull, which brings the motion. So what is the cause of motion? Cause of motion is force. So simply force is a push or pull, which we have already done. But the question arises now that can force be seen or tasted? The answer will be no. We cannot see the force, we cannot taste the force, but we can feel its presence. How we can feel its presence? Then how do you know there is a force? Because of its effects. Yes, because whenever force will be applied, there will be some effects due to which we will be able to come to know about that force has been applied. So effects of force, we know that effects means result. So what happens when the force is applied somewhere on some object at some place? So let's discuss one by one. First is when the force will be applied, its possibility that the body is at rest will be come to in motion. Like you can see on screen, if the player will kick that football, it will come to the motion and it will go to the keeper, goalkeeper, right? So that means kicking the ball is pushing just, right? So pushing is a force, right? So kick is used to change from rest to motion. This is one example. Another effect of force is motion to rest. Yes, by applying the force, we can bring the object at rest when it is in motion. You can see on the screen the player is trying to catch the ball. When he will catch the ball will come to in motion, into rest. Earlier it was in motion, right? So this is happening due to this force. Okay. Next is change in speed. Yes, change in speed we can also create when we will apply the force. You can see, you might have seen this device in the cars. This is accelerator and brake, right? Brake and accelerator. So we know that accelerator changes the speed, it increases the speed, and brakes, when we apply brakes, it decreases the speed. So in both the cases, whether we are pulling or pushing the accelerator or brakes, we are applying the force. So in one case, force will increase, speed will increase, and in another case, speed will decrease. Right? So here, change in speed. Then the next is change in direction. Force can change the direction. Generally, the kids are playing cricket. While playing cricket, when we are hitting the ball with bat, that means we are changing the direction. Same way the player is trying to do on the screen, it hits the ball to change the direction. So we can say that force is used to change the direction. Okay, change in shape. Yes, by applying force, we can change the shape. As you can see, the potter is molding the clay, right? When we are applying the force on a balloon, air-filled balloon, the shape changes. So there are many examples in which the force is applied and the shape is changing. So what are these effects of force? Rest to motion, motion to rest, change in speed, change in direction, and change in shape. So dear children, all these are effects of force. It's not possible that all the effects will take place. Any one, any two can be taking place in the examples or in the situations, right? So these are the effects of force. Keep in mind. Now the question, are there different kinds of forces? Like I am applying the force, then it will create motion. So every time when I will apply the force, it will create motion. The answer is no, right? Why? Because there are different kinds of forces. How we can define these forces? What I mean by these forces? So there are two types of basically forces. One is balanced and another is unbalanced. So as from its name, it's very clear that balanced and unbalanced forces. So balanced forces, when we are applying the force, in class 8 we have studied about force chapter. In that chapter we discussed about the net force. The net force is responsible, or we can define the balanced and unbalanced force with the help of net force. So when the net force is 0, the forces are said to be balanced. When the net force is not 0, then the forces are said to be unbalanced. Or what we can say, when two or more forces are acting on the object, but they are equal in magnitude and opposite in direction, right? Then the forces are said to be balanced. As you can see here on the screen, the book is lying on the table, but it's not moving. So what does it mean? It means that the book is under the effect of balanced force. How the balanced force? One force is applied in the upward direction, another force is applied in the downward direction. So who are applying the forces? The table is exerting an upward force on the book and the weight of the book is in the downward direction. Now in this case, these two forces are equal, right? That's why they are balanced. Now comes to the unbalanced forces. When the forces are there, number of forces are there acting on the object and they are not equal in magnitude, right? Acting on the same body, then the forces are said to be unbalanced. So this swing you might have seen, the seesaw, right? So one child is at the more height, one is at the bottom. That means the forces are unbalanced. So when they will apply the balanced force, then they will be at the equal height, right? So this is the meaning of balanced and unbalanced forces. One more interesting fact about balanced force is that it's not necessary that they are applied on the body and the body will be at rest. That means when the body is at rest, it is under the effect of only balanced force. And when the body is in motion, then the unbalanced forces are responsible. There is one case, dear children, when the body is in uniform motion, then also the body will be under the effect of balanced force. Right? Unbalanced force will not be there. Now the second point is they do not change the state when the forces are balanced, obviously, right? Of rest or of uniform motion. Change the state of rest or of motion, and we know that when the change of state of rest or motion hoga to causes acceleration in the body. So change in velocity upon time, that we all know. Clear? So this is about balanced and unbalanced forces. Now one more new term which we are going to study about, that is inertia. Inertia means the laziness, we can say the laziness of the object, that if the object is placed somewhere, then the object will not move on its own. Let's see by looking at this example. So inertia means resist. It will resist the change. It will not allow or accept that change. So inertia is a natural tendency of an object to resist a change in its state of rest or of motion. So as you can see, when we are keeping something on the car, we are tying it with the ropes, right? We have to, otherwise they will fall down. Why? Due to inertia. In another word, we can say the mass of an object is a measure of inertia. How? Greater the mass, greater is inertia. You will better understand by looking on the screen now. Here we have two objects, right? One is plastic ball, another is stone of same size. Now if I want to move or change their state, in which case I will be needing greater force. Obviously stone. Why? Because of mass. Because mass of stone is more as compared to plastic ball, that's why I will be needing more force in that case. Right? Now ball and stone are of same size but they have different masses, so they will be needing greater force to bring about a change due to its inertia. So inertia के लिए हमें जरूरत पड़ेगी, right, ज्यादा मास के लिए. This is very common example in our NCERT book, or at home you can see or perform that. Keep a coin on the cardboard and flick that cardboard, then the coin will fall in the glass. Why? Due to inertia. Because due to inertia, that is, it will resist the change. It will not allow itself to change along with the motion. When we flicked, the cardboard will move, but the coin will fall in the glass. Right? This is all happening due to inertia. Now, on behalf of this, there was a famous scientist, as I told you, who gave his law on force and motion and presented three fundamental laws, that is Newton's law of motion. So there are three laws. We are going to discuss it one by one. So first is the Newton's first law of motion. So Newton's first law states that when the object is at state of rest or in uniform motion in a straight line, unless compelled to change that state by an applied force. जब तक फोर्स नहीं लगाओगे तब तक बॉडी मोशन में रहेगी या रेस्ट पे रहेगी. So if you remember, this means it's showing that same kind of thing, that is inertia. So we are taking this example. Here is a football. The ball is at rest, but when I will apply the force by kicking that ball, it will come to motion. So it needs an external force to bring the motion. We can say that about this law in another way. As I was telling you, all objects resist a change in their state of motion, and resist means we have discussed in inertia, right? Resist is nothing but inertia. So Newton's first law of motion can also be stated as the law of inertia. So implication of first law implies when an unbalanced external force acts on an object, its velocity changes, right? There is one more thing, that Newton's first law of motion defines force. If in exam it comes, which law of motion defines force? Newton's first law of motion. What is another name of Newton's first law of motion? The law of inertia, right? So I hope you have understood this topic. Keep on watching for the rest of the topic. Thank you so much.